Good afternoon, dear students. So, today we will start sequence and series. It's a long awaited topic. Sequence and series in NDA, there will be around 3 to 4 questions is going to come in from sequence and series. Basically, this sequence and series, it is very important nowadays. In CET also it is there, in JEE Mains also there. So, the level of question in NDA, the CET, this NDA question of sequence series is bit high. It's not basic. One or two question will be simple, one question, but the rest of the questions are little tricky one. So go through this topic. I'm just elaborating the basics, and then we will have couple of problems, and then all of you have to solve couple of homework questions. Okay? So we'll start with sequence and series. Sequence. First of all, we have to understand the meaning of sequence. Sequence is an arrangement of numbers. Let's say 1, 2, 3, 4, 1 by 2, 1 by 4, 1 by 8, correct? This is 2, 2 square, 2 cube, and so on. These are sequence, arrangement of numbers, correct? Sequence becomes progression. Progression means is between two consecutive, any sequence between two consecutive, there is some mathematical relationship. There is some relationship which is mathematical, is known as progression between two consecutive number. Correct there? Between two consecutive, there is some mathematical relation. Then we can say sequence is progression. Correct? Now progression is divided into three parts. First is known as arithmetic progression, AP. So AP must be sequence, AP must be a progression, and then arithmetic progression says a sequence between consecutive term, there is some mathematical relationship, and that mathematical relationship is common difference. So if a sequence which having common difference is known as arithmetic progression. See, this sequence between two consecutive, there is mathematical relationship, 2 minus 1, 3 minus 2. So it is a progression, and this progression, if it carries common difference constant, means 2 minus 1, 1, 3 minus 2, 1, 4 minus 3, 1, then it is said to be arithmetic progression. Correct there? Arithmetic progression. We represent the terms like A, T2, A plus D. Common difference is D. A is first term. Fine. All of you aware of these basics. A plus D second term. Third term is going to be A plus 2D, and so on. Tn is A plus n minus 1 into D. So this is known as nth term of an AP. Tn is A plus n minus 1 into D. A is first term, D is common difference. Correct there? So this we have spoken about arithmetic progression, where Tn is A plus n minus 1 into D. Now, in arithmetic progression, let's say 2, 4, 6, 8 and so on, it is an arithmetic progression. So, we have sum of n terms of an AP also. Correct here? Means like Tn we have seen AP, that A plus n minus 1 into D. Similarly, we have sum of n terms when you have to add this. Let's see, series is 2 plus 4 plus 6 plus 8 up to n terms. Correct? So we have formula n by 2, 2a plus n minus 1 into d. Correct? And we have also result n by 2, a plus last term. Last term is a plus n minus 1 into d. So these basics I believe all of you aware. Sn of an AP is n by 2, 2a plus n minus 1 into d. And here n by 2, a plus l is last term. Correct there? So this is basic about arithmetic progression. Now we will move to, in this Tn we came to know sum of n terms of an AP. Now we will have the consecutive terms of an AP. Three consecutive terms. Consecutive terms. A minus D, A plus D. This consecutive terms mean it can be from anywhere. Let's say 61, 62, 63 term of an AP. Let's say 71, 72, 73 term of an AP. That is the meaning of consecutive terms. Correct? So A minus D, A plus D. If you have 4 consecutive terms, that is a minus 3d, a minus d, a plus d and a plus 3d. This is 4 consecutive terms of an AP. 5 consecutive terms, a minus 2d, a minus d, a plus d, a plus 2d. See, this is important to remember because sometimes in NDA the question is designed on these consecutive terms questions. So you must to know 3, 4 and 5th consecutive terms of an AP. As well as GP also you have to remember that we will write in GP. So these are consecutive terms of an AP. 3 consecutive, 4 consecutive and 5 consecutive terms. Correct? So now these are basic information. Now we'll move to arithmetic mean of a arithmetic mean. This what says? Suppose A, B, C are in AP. Correct? So B is A plus C by 2. We can write B minus A equals to C minus B. So this B is known as arithmetic mean of ABC. Correct? And this is also known as face of arithmetic progression. Face of arithmetic progression means, let's say whenever it is written that anything is in AP, let's say sin inverse x, sin inverse y, sin inverse z are in AP. So what you will write? Sin inverse y equals to sin inverse x plus sin inverse z upon 2. Let's say angles are in AP. So angle B equals to angle A plus angle C by 2. That is why this arithmetic mean is also known as face of an AP. जब भी हम AP की बात करेंगे तो उसकी फेस हम ये अर्थमेटिक मीन ही लिख देते हैं, B इक्वल्स टू A प्लस सी बाई 2, जो हम प्रॉब्लम्स में ऑपरेट करते हैं कि ABC लिखी हुई AP में तो डायरेक्टली वी राइट 2B इक्वल्स टू A प्लस सी और B इक्वल्स टू A प्लस सी बाई 2. That is what arithmetic mean. And arithmetic mean between ABC we have B equals to A plus C by 2. We have arithmetic mean in a arithmetic progression. N number of arithmetic means is possible. Let's say A, B, C, D, E, F and so on are in AP. So B is arithmetic mean of AC. C is arithmetic mean of BD, correct? And then D is arithmetic mean of CE, correct? So n number of arithmetic means is also possible in AP, correct there? So A and C, B is arithmetic mean, B, C, D, if it is B, C, D, AP, here again, C is arithmetic mean of B and D. Take an example, you will come to know 2, 4, 6, 2, 4, 6, 8, 10. So 4 is arithmetic mean of this, fine. 6 is arithmetic mean of 4 and 8, fine. 6, 10, 8 is the arithmetic mean of 6 and 10. So n number of arithmetic means we can insert in an AP, correct Dave? So this is basic about arithmetic progression. इतना डेयर अपने को कंपलसरी समझ के लेना है AP के अंदर, उसके TN और SM. Now the question comes, can we have S infinity of an AP? This question comes in our mind. क्या हमें S infinity मिलेगा AP को? S infinity of an AP, whether it is exist or not. See, when we talk about sum, when we have to sum it, we know the end, correct? Suppose you have to count the students in a college. So you know the end of the college because this is the college and here all these students are enrolled. So we know the end of the domain, so that from where we can get the sum. So what happens when we have 2, 4, 6, 8, if it is plus and it is going till infinity, we don't know the end. We don't know the end. So we cannot add. Once you know the end, we can add. Like in GP, we will know that the end is there. That we will discuss in GP. So S infinity of an AP does not exist. Correct? S infinity of AP does not exist. Always remember. Okay? Because we don't know the end. How will you add? Correct? So there, this is about of an AP. So minimum अपने को अर्थमेटिक प्रोग्रेशन में इतने बेसिक इंफॉर्मेशन ध्यान रखने हैं, करेक्ट? सो नाउ वी विल मूव. इसमें एक एंड में एक छोटा सा टर्मिनोलॉजी और मैं ऐड कर दूं. इसको कहते हैं let's say 2 4 6 8, ये आ गया 18 20, this is in AP. The difference of this is difference of this, correct? The difference of this is difference of this, it is there. So remember always, last and second last, the difference, common difference है. So last and second last is equal to, you can write second and first also, because difference is same, right? So these two terms is also equal to first second term. Understood? In AP, because common difference is same, fine. So ये एक छोटी सी चीज है जो कभी कभी problems में we have to apply. Fine there. See, whenever you start solving a problem, what is very important, I have been observed for this last month onwards, very few students are watching videos of my lecture. I don't know why. हो सकता है वो सब कुछ पता होगा आपको. Very good, not bad, अच्छी बात है. बट अगर आप एक बार वीडियो देखेंगे तो you will recap the previous thing. पुरानी चीज़ों को एक बार recap हो जाएगा डियर. ठीक है? I agreed कि आपको ये सब सारे बेसिक चीज़ पता है. मैं भी ऐसा नहीं कि आके मैं सीधा सम और डिफिकल्ट सम बनाने लगूंगा. That is not my job. My job is to train. हो सकता है आप में से कोई बच्चे बहुत बेसिक चीज़ भी नहीं समझ पा रहे होंगे, कोई बच्चे बहुत ज़्यादा समझ रहे हैं. तो अच्छे से वीडियो को देखो और जब होमवर्क दी जाती है आराम से कुल्ली करो. एंड सभी बच्चों से रिक्वेस्ट है, सभी लोग अटेम्प्ट करें. आई हैव सीन वेरी फ्यू स्टूडेंट्स आर गोइंग सॉल्विंग होमवर्क. व्हाई आई डोंट नो, बट इट्स देयर, इट्स अ सिंसियर रिक्वेस्ट. दैट एग्जाम इज वेरी क्लोज. आई थिंक इट इज 1 month or 5 to 6 days left. So start solving problems, and doubt you can ask. Right here. So with this note, I am going to another segment, geometric progression, GP, what we call in short form. In GP, what happens? AR square. I have shown there one sequence, 1/2 square, 1/2q, and so on. Correct? ARQ and so on. AR and minus 1. See, in geometric progression, what happens? The second term upon first is equals to third upon second. Means the ratio between the terms are constant, correct? Means look at this, 1/2, 1/2 square, 1/2q, 1/2 4, it is going. So 1/2 square upon 1/2, which will give you 1/2. 1/2q upon 1/2 square, this is again, it will give 1/2, and these are known as ratio, common ratio, CR, common ratio, correct? So in GP, what happens between two conjugative terms? The ratio is constant. Second term upon first, third upon second, fourth upon third. So this is known as geometric progression. The first term is A, second term is AR square. This is common ratio. ARQ third. So nth term is AR, A into R to the power n minus 1. That is nth term of a GP. Clear? So GP is important for NDA. GP के सम्स ज़्यादा होते हैं, ठीक है? So in GP we have seen AR square, ARQ are the term. TN is, nth term is A into R to the power n minus 1. Correct? Now we'll talk about sum of n terms of a GP. ठीक है? See, जो common ratio होती है, एक छोटा सा एक क्वेश्चन है डियर, बड़ा इंटरेस्टिंग सा क्वेश्चन है, कई बच्चे कंफ्यूज होते हैं. मैं उसको पहले डिस्कस कर लूँ. लेट्स से आई हैव रिटन 2 2 2 2 2 4 4 4 4. क्या ये जीपी में है? कई बच्चे कंफ्यूज होते हैं. ये सर ये जीपी में है क्योंकि सबके रेशियो 1 आ रहा है, कांस्टेंट आ रहा है. नो, इट इज नॉट इन जीपी. करेक्ट? सम करते समय हम जीपी भी नहीं समझते, इसको हम n टाइम्स ऑफ 2 कर देंगे. But these are not in GP. Let's say 0.1, 0.1, 0.1, so on. क्या ये GP में है? No, it is not in GP. The question comes why? Question is the ratio never be 1. Always remember, अगर ratio 1 हो गई तो रेशियो कंपैरिजन की कोई बात ही नहीं होगी. दो नंबर यू कैन नॉट कंपेयर because comparing of two things, ratio came into mathematics. Fine. So ratio never be 1. So these are not in GP. Always remember. Fine. So when r is not equal to 1, so there are two possibilities: r less than 1 and r greater than 1. Ratio never be 0. Correct? Those basic things all of you aware. Ratio never be 0. So r less than 1 and r greater than 1. So for sum of n terms, we have two results. When r less than 1, we have 1 minus r to the power n upon 1 minus r. When r less than 1. When r greater than 1, then we have this result, r minus 1, r greater than 1. Minus you take common, numerator and denominator, this will get. So we have for Sn two results depending upon the value of r. If r less than 1, we have a into 1 minus r to the power n. If r greater than 1, then r to the power n minus 1 upon r minus 1. A is first term. A is first term. Correct? So these two formula compulsory you have to remember. So Tn we talk about, Sn we have already discussed. Where r less than 1 and r greater than 1, we have two results. Fine here. Now we will move to S infinity of a GP. See, we have sequence AR square, AR cube till infinity. Correct? Now we are looking sum of infinite terms of a GP. There we can get a S infinity of a GP, but the condition is that common ratio must be less than 1. If r greater than 1, then we cannot get the sum in S infinity of a GP. Fine. So S infinity of GP will exist when r less than 1. So S infinity exists if r less than 1. Correct? Now the question comes, how? How you can say when r less than 1, S infinity will exist? Look at this one example. If I have taken 1 by 2, 1 by 2 square, 1 by 2 cube, and so on. Look at this sequence which is in GP is decreasing 1 by 2, 1 by 4, 1 by 8, 1 by 16 and so on if it go 1 by 2 to the power n. Fine. So अगर हम यहाँ n tends to infinity लगाएंगे तो ये quantity क्या हो जाएगी? You know, in limit 2 to the power n it becomes 0. Fine. So ये term we have 0. So that means we know the end. We know the end now. So we can add. Correct? So we can get the solution. Taken a very common example. Suppose एक रोटी का टुकड़ा है, उसको आपने 2 हिस्सों में काटा, 4 हिस्सों में काटा, 50 हिस्सों में काटा, सबको बांट दिया. एंड में आपको कुछ नहीं मिला, 0 रोटी मिल गई. और फिर आपने सबको बोला वापस करो, तो फिर से एक रोटी बन गई. करेक्ट? तो when you distribute it, so at the end you don't have you left with 0 only. So 0 is the end. Now again if you call कि सब वापस करो मुझे सारी रोटी, तो मैं एक रोटी फिर से बना दूंगा. That means any S infinity of a GP will exist when r less than 1, so that we can get the end of the sequence. Correct? Understood? So this GP has S infinity. The condition r should be less than 1. Fine. So S infinity of GP we can calculate, and there one sum it is there in NDA based on S infinity. Correct? So that is again an interesting area. So that we'll do a couple of sums based on this. Now we'll talk about geometric mean. ठीक है? Geometric mean A, B, C are in GP. Fine. So B square equals to AC we can write B upon A. Correct? B upon A equals to C upon B. So B square equals to AC. And this B is known as geometric mean of ABC. Correct? Suppose A, B, C, D, E, F are in GP. We'll get all GMs also. And GMs also we can get, like you have seen in AM. Correct? So geometric mean A, B, C are in GP. So geometric mean B is root AC or B square equals to AC. b is root AC or b square equals to AC. That is known as geometric mean. Fine. So we came to know GP, there Tn, Sn, S infinity and geometric mean. Now there, between AM and GM we have one relationship. Relationship is AM is greater than GM. AM is greater than GM. Remember, arithmetic mean is greater than equal to भी लिखते हैं कभी कभी, but greater, strictly greater is correct. So AM is greater than equal to GM. Right? That means A plus B by 2 greater than equals to root AB. This is also known as arithmetic geometric inequality. ये भी inequality हम mathematics में use करते हैं डियर. AM GM inequality कहते हैं इसको. So A plus B by 2 greater than root AB. Fine. So we have seen till here sequence, then progression, then types of progression, arithmetic progression, their Tn, their Sn. S infinity does not exist in AP. Then we have seen GP, conjugative terms of an AP, 3 conjugative, 4 conjugative, 5 conjugative terms. Then we came to know geometric progression. Fine, the geometric progression Tn, Sn. In geometric progression also we have 3 conjugative terms. 3 conjugative terms. A by R, A and AR. Fine. Here it is upon, there it is A minus D. 4 conjugative terms. A by R cube, A by R, AR, AR cube. 5 conjugative terms. A by R square, A by R, AR, AR square. Correct? See, there are 6, 7, 8 भी होते हैं conjugative term. बट अपने को 3, 4, 5 तक ही कंजुगेटिव टर्म्स दिमाग में रखने हैं, एपी के भी और जीपी के भी. ठीक है डियर. सो ये हमने एपी और जीपी के इंफॉर्मेशन कलेक्ट किए. ठीक है. नाउ वी हैव लेफ्ट विथ वन विच इज हार्मोनिक प्रोग्रेशन. राइट. हार्मोनिक प्रोग्रेशन. सी, हार्मोनिक प्रोग्रेशन हैज बहुत ज़्यादा रोल नहीं है सीक्वेंस सीरीज में, बिकॉज हार्मोनिक प्रोग्रेशन को हम एपी में कन्वर्ट कर लेते हैं. लुक एट दिस. ए बी सी आर इन एच पी, अगर मैं बोलता हूं इसको एच पी, ए बी सी आर इन एच पी, दैट मीन्स इसका जो रेसिप्रोकल है 1 बाई ए, 1 बाई बी, 1 बाई सी, इसको यहाँ कंपल्सरी एपी में होना चाहिए. ठीक है. अगर ए बी सी एच पी में है, दैट इट मीन्स उसका रेसिप्रोकल एपी में होना चाहिए, मस्ट. ठीक है. लेट्स से 1 बाई 2, 1 बाई 4, 1 बाई 6 आर इन एच पी. ठीक है. सो विल चेक देयर रेसिप्रोकल्स. 2, 4, 6 एपी में है. करेक्ट. दैट मीन्स दिस इज इन एच पी. फाइन. सो whenever we have HP, harmonic progression, we immediately convert to AP, and then we get the sum of n terms. Whatever Tn, Sn you can calculate. So we did not have to learn Tn of HP, Sn of HP. No need to learn. Correct. What we have to do, we have to make it in terms of an AP, and then we know Tn and Sn. At the end you convert in Sn and Tn, so that we will get the sum and Tn of HP. At the end, once you calculate the Tn of AP, and then finally you convert the Tn to HP 1 upon this. Find here. In HP, what is very important is harmonic mean. This is very important. Harmonic mean of harmonic progression. See, now this is A, B, C are in, let's say in HP. Correct? So, B equals to 2AC upon A plus C is known as harmonic mean. Remember, this is very important result. अगर ये रिजल्ट याद रहता है तो यू कैन सॉल्व कपल ऑफ सम्स इन एनडीए. एनडीए में बड़े बेसिक क्वेश्चन इससे पूछे जाते हैं. ठीक है. So harmonic mean is B equals to 2AC upon A plus C. Fine here. So अभी इस वीडियो में मैंने बेसिक इंट्रोडक्शन किया है सीक्वेंस के बारे में और प्रोग्रेशन के बारे में, एपी, जीपी एंड एचपी. ठीक है. सो नाउ वी विल मूव सम प्रॉब्लम्स बेस्ड ऑन एपी, जीपी, एचपी. सेकेंड पार्ट इज सीरीज, सीक्वेंस एंड सीरीज. सीरीज को हम नेक्स्ट क्लास में डिस्कस करेंगे. अभी हम सीक्वेंस पे डिस्कस कर रहे हैं. ऑल्दो हमने सम ऑफ एटम्स ले लिया है जीपी, एपी का. सीरीज क्या है डियर? सीरीज इज सम ऑफ सीक्वेंस. ठीक है. तो सीक्वेंस एंड सीरीज टॉपिक का नाम है. सीरीज मतलब सम ऑफ सीक्वेंस. एपी का देख लिया आपने सम, जीपी का आपने सम देख लिया. वो सीरीज के अंदर हम सम स्पेशल सीरीज डिस्कस करते हैं, इसलिए सीरीज को अलग सेगमेंट में रखें. ठीक है. सो नाउ वी विल go for couple of problems based on AP, GP and HP. Fine.